Hello, welcome. That's a lot of you interested in testing. Cool. All right, well, thank you guys all for coming. Well, before we start, let's just do a quick sound check. Can everyone who can hear me raise their hand? Marvelous. So I already know two things about you. Well, first of all, you didn't read the information about the earplugs, and you didn't take them with you. That's great, so you can hear me. But secondly, I know that I can ask you questions. That's great. I'll use that opportunity later on. But before we go there, let me just quickly introduce myself. So my name is Jan Molak. I'm an independent consultant, trainer. I work with teams around the world, helping them deliver better software. And as a side effect of this work, I also contribute to the open source community. And there are quite a few open source projects that I've published recently, but one of those is the one I would like to tell you more about today, and that one is called Serenity JS. So if there are any questions that you guys might have that are not answered during this talk, or you don't manage to find me during this conference, please feel free to drop me a line or contact me using any regular social media channels. Okay, so Serenity JS is an acceptance testing library. So let's just try to use this newly acquired superpower of mine of asking you questions. So here's the first question. Have you ever witnessed a project doing test automation? Awesome. Please keep your hand up if you enjoyed what you've seen. Cool. So some of those hands have gone down, some stay up. That's great. So let's talk a little bit more about what good automated tests look like. What are the properties of those tests that we are looking for? What are the characteristics? So my friend John Ferguson Smart likes to describe those good automated tests as being fast. So what does this acronym actually mean? Well, first of all, good automated tests should be fast to run, right? If I need to wait for several hours to get my test results, they're rubbish. They don't give me any value. So that's not good. Now, they should also be fast to write. If I need to spend hours figuring out where to add my tests, well, again, this is waste. This is not what I want. They should also be fast to give me feedback. If I need to wait for days to figure out what the outcome is, again, that's a problem. By the time I get this feedback, I've already forgotten about the functionality that I've added, right? And on the note of reporting, the test results should also be actionable. So if my tests are slow, if they take hours to run, if the only way that they communicate the failure is a huge stack trace, they're not particularly actionable, right? I don't necessarily know how to address the failure, where the problem is. I need to, again, spend time investigating the issue, analyzing the problem. And this applies as well to the technical audience as well as to the business audience. So if I tell the business that, well, we've got tests failing, the first question will be, okay, which feature is affected? Well, I don't know, I can show you the stack trace, right? So that's not particularly useful. Now, the first property is scalability. Now, as technical people, as engineers, we like to think of scalability in terms of, again, speed and performance of our tests, right? So how fast can they run? How much iron I can throw at the problem now? How many tests I can run in parallel? But that's only one aspect of scalability I'm interested in. Another one is how quickly can I add new tests, and how does this speed change as the product grows, as new tests are being added? But also, how long does it take a new person joining the team to figure out where to add things? How long it will take them to learn about the code base? So those are all the aspects of scalability that good tests should fulfill. Now, the last part of this acronym is trustworthiness. So obviously, the tests should only fail if there's an application failure. If the tests fail for random reasons, that's not useful. Because then I lose my trust in those tests. The team loses trust in those tests, the business loses trust in those tests, and eventually, quite often, those tests get abandoned, and nobody cares about them. Does this story sound familiar at all? Okay, I see some nods, lovely. So again, this is quite a common problem, and I see this problem very, very often. But if you think about it, none of us, when we write software, wants to write a crappy piece of code, right? It's never our goal. Then why does this happen with automated tests? Why do they get slow? Why do they get abandoned? Why are they useless? So to look a bit more into why this happens and how we can avoid those pitfalls, let's look at a concrete example. So how would we test a user story? I suppose we all here work on some sort of an agile team. Cool, so that's the right conference, awesome. Okay, so let's consider a practical example. So what I quite like is the example of the journey planner. Have any of you ever tried to plan a journey online? Let's say train journey from one place to another. Cool, so this is not a completely new domain, brilliant. So the user story I would like us to consider looks as follows. So we have a commuter, and they want to know the fastest route between two places so that they can get to their destination as quickly as possible. Now, the first question that we need to answer when we start working on such a story is, when do we write the tests for it? When do we write the acceptance tests? So there are, well, two main forks in the road. We can either write the tests before we start implementing the story, or we can write them after. As someone recently pointed out to me, we can also skip the process altogether. Yes, I haven't considered that option earlier. Let's forget about it for now. So if we think about writing tests after we've written the story, we're mostly thinking of writing those tests as a way of verifying our implementation, as a way of providing a safety net around this implementation, right? So basically, what we're doing is we're creating a safety net. We're creating a regression pack once the story is implemented. Now, if we were thinking of writing those tests before, we'll probably consider a process like TDD or BDD that would allow us to test drive the entire implementation. And this is all very obvious. I'm sure you're all very familiar with this whole domain. But now, there's an interesting problem with writing tests after the story is completed. So first of all, we've got some limited testing opportunities. So if the story hasn't been implemented with testing or testability in mind, we might only have several interfaces available to us for writing those automated tests. For example, just the UI. Now, because those interfaces are quite limited, the regression tests implemented after the story is implemented tend to be quite UI heavy. So they rely on the user interface to be present, to be working, and so on. Now, what this makes them, it makes them slow and flaky. And that's a very common problem with full stack end-to-end UI-based tests. But there's another more subtle aspect to this whole thing. So they only verify our implementation. So they can confirm that our understanding of the story was correct, that we've implemented this as per the requirements, but those tests won't validate the requirements. So they won't help us discover the gaps in the stories. Okay, so on the other side of the spectrum, well, we've got BDD, right? So we're promised that we'll have testability built into the system as we evolve it. We'll have our tests business focused, so they won't be tangled to the UI. They won't be relying on the UI to be present. And they also help us validate the user story, validate the scenarios, as well as verify the implementation. So that sounds great, right? Okay. So let's see how this works in practice. So here what we have is a scenario, an example scenario demonstrating this feature. And that's a scenario that we could have been given by our business analyst or a product owner, and it demonstrates how the feature should behave. So we could say that, well, given the Jubilee Line trains leave Canary Wharf, at 1 minute to 5 or 1 minute past 5, when Connie, and Connie is our user persona in this case, when she wants to travel from Canary Wharf to Waterloo at 5, then she should be told about the train at 5:01. Does this make sense? Cool. But if we think about this scenario, there are actually trains leaving both directions from the station, right? So they could be leaving from Stratford or towards Stratford. Also, if it's already 5 o'clock, should we really be telling Connie about the train at 5:01? Does it make sense? Will she have enough time to get the ticket, go to the right platform, find the train? Well, that's obviously silly, right? So we can use this opportunity, as we discuss the scenario, an example with our product owners or BAs, to explore this story further. So perhaps we should give Connie more opportunities to find the right train. And as you can see, so far, this process works pretty well. So we managed to find some ambiguities. We managed to find a better implementation of our system. We managed to capture it in a scenario. Great. And if you think about it, it's quite an important thing to do, because between 44 to 80% of all software defects are caused by unclear, ambiguous, and incorrect requirements. So I often have this conversation whether it's actually worth using tools like Cucumber or JBehave, whether it's worth doing BDD. Yeah, it is, because we can actually eliminate whole classes of errors, whole classes of problems, whole classes of ambiguities. And I didn't just make up those numbers, there are actual studies backing those up. So that's all great. So those are specifications, and we got this topic covered pretty well. But how does this work in practice? How do we make those specifications executable? Because one of the main things about BDD is making specifications executable, right? So that we can actually run them against the system and we can verify the correct behavior at any point in time. So what typically happens is this. If we build a web-based system, well, we obviously know that the user will be interacting with the web browser, right? The web browser will send some messages through the pipes that as we know, the internet is built of, and those messages will finally hit our system and give us back some responses. So far, so good. Now, there are certain assumptions that we make about the system and about our approach to test automations that are quite common in our community. So, first of all, we like to treat acceptance tests as things that think about the system as a black box, right? So the automated tests should not have any knowledge of the system that's actually being tested, and that's quite a common assumption. I mean, even if you think about it, even the extreme programming website, the old one, talks about acceptance tests as black box system tests. So again, we want to test the system end to end, and we want to consider it being a black box. Now, another assumption that we make is that the tests should exercise the system as the user would. Well, obviously, if acceptance tests are also called user tests, right, or customer tests, then they should be exercising the system in a very same way, probably through the browser. Also, one of the things about behavior-driven development is that we should favor outside-in development over inside-out development, right? So again, what is the most outside layer of our system? The UI, right? Therefore, the only logical conclusion that we can draw based on those preconditions is that the way we should automate our tests is by wiring up Cucumber with something like Selenium and exercising the system through the UI. Does this sound familiar? Okay. What's the consequence of that? Well, first of all, we end up with limited testing opportunities because we're testing the system through the UI and UI only. Our tests become UI heavy, and not only that, they also become UI dependent. So how do we actually test drive the system that doesn't have the UI yet? Do we wait for the UI to actually be built before we can run our tests? If so, we're just doing regression testing again, right? Now, if our tests are UI-based, if they exercise the whole system, if they treat us as a black box, what they become? They become slow, they become flaky, and eventually abandoned. Now, even if you think about the popular ways of structuring those tests, so for example, using page objects, those do not help you avoid this problem. Because page objects do not give you any additional layer of abstraction. The tests are still tied directly to the UI. Page objects just repackage the WebDriver scripts. Now, this whole problem becomes more apparent once our system gains more than one delivery channel. So what happens if we suddenly introduce a mobile app to our product? Well, we probably need to have a separate set of acceptance tests exercising the mobile app, where we duplicate all the testing code, where we duplicate all the scenarios. So that's what we end up with, right? And we've been promised this magical land of unicorns and rainbows where everything is test-driven and lovely. Where did that go? How did that happen? Have you ever heard of the test pyramid? Okay. So we might argue that what we just done is we've violated the test pyramid, right? Because we went with UI-heavy test base, everything is executed through the UI, both the mobile tests and the web tests and so on. So that's obviously a problem. And our test pyramid became a software testing ice cream cone, which is an anti-pattern, right? And that's a problem. So the test pyramid is a model devised by Mike Conant, which he described in his book Succeeding with Agile years ago, where he's suggesting that a well-structured test automation suite should comprise of mostly unit tests. It should have some service-based tests and just a few UI-based tests, which is all nice and great, but it doesn't really address how we should avoid this problem. Now, the software testing ice cream cone describes the situation that we're just in. So, well, we've got loads of UI tests, some service tests, and not so many unit tests. But the main question here is, how do we actually fix that? So if you look up testing pyramid on Google, you'll find quite a few results. And most articles I managed to find on the subject of test pyramid will tell you that, well, the problem is obviously caused by the fact that you've got too many UI tests, not enough unit tests. Well, fine, that's useful. How do I fix that, right? Well, you should have more unit tests than UI-based tests. Well, cool. And some articles will even go as far as suggesting that, well, you should only have 5% UI-based tests, 15% of... Fine, okay, what do I count? The lines of code, the number of tests, the complexity, how do I do it? The trouble is that neither one of those articles actually addresses the root cause of the problem. Well, first of all, those UI-based tests cannot be simply replaced with unit tests because they serve a different purpose. So those tests that we are executing against the UI are acceptance tests, right? They're business-facing, they provide business value, and unit tests are typically technology-facing tests. So they're slightly orthogonal concepts. So we can't just replace one with the other. So how do we deal with that? My advice to you, forget about the pyramid. I don't think it's particularly useful. Well, the way I like to look at it is using this little testing quadrant that used to be a square on my screen. Anyway, I like to look at those automated tests from two angles. So the perspective of the audience and the perspective of the speed of feedback and quality of feedback. So if you think about it, all the acceptance tests, all the automated tests that we write will basically have two types of audience. Either the technical audience or the business audience, right? For the technical audience, well, we need to know if the test fails and what part of the system failed, well, what line is affected, what functions are affected, and so on, so that we can fix it. And from the business point of view, we need to know what features, what capabilities of the system are affected. Can we release the system or not? Now, the perspective of feedback can tell us whether a given test gives us feedback that's fast, cheap, and precise, like unit tests do, or is the type of feedback slow, expensive, and broad? It's not that one is better than the other. Well, obviously, we like to have our results fast, but some tests, like the integration test or performance tests, will, by definition, be slow and expensive. But the problem is that we don't really have business-facing tests that are fast, cheap, and precise, because we're only relying on the UI-based tests that, by definitions, are slow and flaky. So how do we deal with that? So let's talk about the multiple levels of executable specifications. Now, obviously, no talk on the topic of BDD could be complete without at least one quote from Dan North. So here it is. So as you probably know, Dan explains BDD as a way of using examples at multiple levels to create a shared understanding. But could we also do acceptance testing at multiple levels of our system? Could we take this recommendation further? So let's look at the system we talked about before, right? So we've got a big black box that exposes the web UI and maybe a mobile UI. But let's think about the size of this black box, right? If our black box is the entire system, then we just paint ourselves into a corner. The only option we have is to use the outermost interface of such system. But this system is typically composed of a number of different components. It will have different interfaces that we can interact with, like the UI, like the REST API, like messaging queues, and so on. And it might also have a better or worse designed domain layer, or the business logic layer, or domain core. Now, if you look at the system from this perspective, we might just consider the whole ecosystem in which our application lives as comprised of actors who interact with different interfaces of such system in order to use the business logic that we've developed. Now, if that's the case, then what those different interfaces and UIs are, they're just different adapters for our business logic. Okay? So if now we also note that those adapters should not make any changes to this business logic, they should not add to the business logic, well, then they're just different translation layers of our system. So if this is true, then this means that we should be able to execute the exact same specification against our interaction layer, so the UI or the mobile app, against the interfaces directly. So the same scenario in which we plan a journey, in which we want to find trains, in which we want to see the responses, could also apply to the REST interface, for instance. But also, more interestingly, we could also run those tests against the domain layer itself. Why not? If we are using things like the hexagonal architecture or ports and adapters architecture, then all our business logic should be encapsulated within the domain core. Well, if that's the case, then our acceptance tests could just become yet another adapter to this hexagon, right? So we could actually run our tests against the business core. What this means is that we shouldn't really be tied to running the tests through the outermost interface of the system, or even the REST API. We could just run them against our aggregate routes if we're using DDD and hexagon architectures, which basically means that we can run all those executable specifications in milliseconds. this can become very, very fast, because that's the only part of the system that actually holds any logic. That's worth testing. Obviously, our automated test suite could not be composed of only those tests that run against the core of the system. We need to have some tests that exercise outer layers as well. However, most of those tests could again run just against this business core. How do we do this? Okay. So if I haven't lost you already, let's talk a little bit more about actual implementation of those ideas. Because theory is great, but how do we get the code? How do we make this work? So let's talk about the scenario decomposition. So that's a technique I like to use to decompose cucumber scenarios. And that's a technique that's based on a user-centered design technique that's called hierarchical task analysis. That's been developed in late 60s and was used to better understand different tasks and interactions of people working in the steel industry and factories. So let's consider one of the steps of our scenario. When Connie wants to travel from Canary Wharf to Waterloo at 5 o'clock. So the first step here is to figure out who the actor is. Now, that sometimes might be already a tricky part. I've recently seen a bunch of user stories that were structured along the lines of as a message bus, as a translation service, I want, so that. Well, obviously those things are not actors in our system. So what we try to do here, we can try to capture the actual actors, so people or external systems interacting with ours. So in this case, I'm using Connie here. So Connie could be a persona that was devised by people in, let's say, the UX team. They very often like to come up with different user personas describing different roles in the system. So let's say we have Connie, right? So Connie becomes our actor. Now, Connie has a goal. She wants to plan a journey. Now, one of the things in hierarchical task analysis is that we try to describe every interaction with the system as from the point of view of the goal. So why are we doing it? Then once we have the goal, we try to break it down into tasks that are actually involved in achieving this goal. So for example, here, if Connie's goal is to plan a journey, well, then the first task could be to open the journey planner. Then she'll need to choose the origin, choose the destination, choose time of departure, and confirm her selection. But as you can see, so far, we haven't talked about the UI at all, right? We're decomposing this scenario from the point of view of the business process. Now, each of those tasks actually is a goal for the tasks that it's composed of. So for example, here, the task to choose origin is basically a goal for tasks to enter Canary Wharf and pick the first suggestion from the drop-down list when it comes to the interacting with the UI. And this is quite a simple exercise that could be done either with sticky notes or just on a whiteboard, just to figure out what is involved into accomplishing a specific scenario. What exactly is involved? Now, what does this look like in terms of code? So what we could do is we could actually take each one of those tasks and create a little DSL, a little domain-specific language describing our domain. So plan a journey could be implemented as a task to, well, plan a journey, quite straightforward, right? Now, the tasks that need to be performed in order to accomplish this one could be then implemented using commands as shown here. So open the journey planner, choose origin, choose destination, etc. Okay? But now, the interesting thing here is not just
designing this domain-specific language, I mean, this is useful, right? And it makes our code much more readable. It makes it easier to find how to interact with specific parts of the system. But what's really useful here is that we could have alternative implementations of those tasks. I mean, there is this crazy thing called polymorphism, right? So we could have the UI implementation of plan journey, but we could as well have a REST API implementation of plan journey. From the point of view of the automated test scenario, still Connie plans a journey. And the scenario doesn't necessarily care if she does so using the web browser or the mobile app or the REST interface, or if she talks to the domain model directly by sending events to it. What this means is that we could actually have our scenarios executed either against each one of those interfaces of the system, but we could also have mixed scenarios. So, for example, in the insurance industry, well, as you probably know, the insurance industry is all about building long and complicated forms, right? So one of the main problems with writing acceptance tests for those insurance systems is how do I get to the 50th page of the form? Because obviously, if I have to go through every single step, the test will become slow. So what we could do with this approach is we could set up the system to be in a specific state where this 50th page is displayed, and then we can perform the assertions on the page itself. So it gives us quite a lot of flexibility. Okay, so all those things that I've just shown you are part of what we call the Screenplay Pattern. So the Screenplay Pattern is something that's originated in the head of Anton Marcano around 2007, if I remember correctly, back when he used to have long hair. Now, you'll probably find more information about the page object pattern and, about the Screenplay pattern and how it's, and its origins in the page objects refactored article I'll link from the presentation. But basically, the idea is quite simple and quite nice. So what we do is we design our systems, our test system and our test scenario using 5 basic interfaces. Okay, so we have an actor. The actor performs tasks, so we've already seen those tasks. And the actor also has abilities, and those abilities enable the actor to perform interactions with the system. Right, so that's the theory part done. Let's look at the practical part. So what you're looking at now is the Serenity JS implementation of the Screenplay pattern. There is also a Java implementation in the Serenity BDD library. But since I'm the author of the JS one, I'll show the JS examples. So, all right, let's start with the actor. If we wanted to create an actor in our tests, we could use this super crazy complicated API to create the actor, which basically requires us to say actor named, and we give it the name of the actor. That's it. Now, the actor will need to have some abilities to interact with the system. Basically, the ability is just an adapter to a specific interface. So we can have an adapter to use the web UI, we can have an adapter to interact with the mobile app, we can have an adapter to interact with the REST API or the domain layer, and so on. Now, the library ships with several of those adapters, but you can very easily write your own. Now, once our actor has some abilities, we can ask them to perform some tasks. And this API is, again, fairly straightforward. Each task is just an object implementing the task interface. And we pass them to the actor by saying actor attempts to, and then giving it a list of tasks. Now, as you already know, those tasks can be composed of lower-level subtasks or other interactions. And that's how we do that. So, for example, a task to plan a journey is a task where actor plans a journey, and then we give it some more tasks to perform. And as you can see, all this stuff is fairly straightforward. Now, the nice advantage of that is that if we have a library of those little tasks that we've already created, we can very easily get new developers onboarded and help them write those acceptance tests because they're just assembling building blocks. And I was actually on a project where I was training 10 manual testers in test automation, and many of those guys have never seen an IDE before. So you can imagine how big of a gap that was. But those guys spent a lot of time with the system being tested, so they had a huge domain knowledge. So what they did is that they guided our development, so we basically created those tasks or building blocks for them, and they could just assemble them and create test scenarios. So this helps with collaboration as well. Now, if we look at any of those tasks that make part of the planner journey, they all follow the same pattern. So it's basically a hierarchy of things that need to happen with the system. And it's very simple composition. Now, the actor can also ask questions about the system. And those questions can be domain specific. So we don't necessarily need to have assertions like assert I'm on this page true. We can give those assertions domain specific meaning. For example, the actor can see that the trade request has been sent or that the journey has been found. And that's how those things will be reported in the test execution report. So how does this whole thing get hooked up with the system? Well, in the case of a web test, well, we can give the ability a client to the browser. So this could be a protractor driver, or a web driver. This could be a HTTP client, and so on. It's basically the ability is just a wrapper around the interface-specific client. So where does Serenity.js fit in the bigger picture? So actually, the project started as a plugin for Protractor, which is the testing library for Angular-based projects. So I created this library as a way of fixing some common problems with Protractor and Cucumber integration around synchronization of scenarios. But then it evolved slightly. So I implemented the Screenplay Pattern and quite a few of those building blocks that I've just shown you guys. So Serenity.js started as an adapter between Cucumber or Mocha and Protractor. But now you can use it without Protractor too. So you can just you can use Serenity.js in your acceptance test. You can create those domain-specific tasks or domain-specific adapters and run tests against any interface of your system. And in case I forgot to tell you about it, Serenity.js is a JavaScript library, so it's for Node.js projects. But I think that's fairly straightforward to figure out. Okay, now all this domain modeling and the domain-specific languages stuff is really nice and helps to keep our code nice and clean. It helps to onboard new people. But that's not all there is to it. So let's talk a bit more about communication. So how do we communicate the results of our tests? So if you think about it, there's a fly. Wow. So if you think about it, unit tests communicate the results in terms of passes and failures, right? So we can say that, I don't know, 97% of our tests have passed. They communicate the results in terms of code coverage. So 98% of our code is covered by unit tests. And this is all great, but it's not particularly useful from the business point of view. One example I like to give here is an example where I witnessed a conversation between a delivery team and a product owner, where the delivery team said that, well, we know that we're under heavy pressure and we've got a deadline to hit. We've got 97% of our tests passing. Dear PO, should we go live? Well, the first question was, sure, but what 3% of tests are failing? Well, we don't know. We need to spend some time analyzing those failures. Well, then perhaps you should do it. And thank God they did, because those 3% of failing tests were all around checkout, and those e-commerce applications, so obviously the ability to pay is quite important. So if you think about it from the point of view of the business, what's important is what features are affected by failing tests, what capabilities of the business are affected by those failing tests, not necessarily how many lines of code we have covered. But thankfully, we can gather all this information as we run our automated tests. So Serenity.js has knowledge of the tasks that the actors execute. But it can also analyze the Cucumber scenarios to figure out what scenarios those tasks are associated with. Now, since scenarios are described in Cucumber feature files, we already have knowledge about the features. And if we group those features into directories, and we give them names related to capabilities of our system, we've got knowledge of capabilities as well. So what this all means is that we can produce a test execution report that at the very high level will tell us about the release readiness of the system. So how many features, how many capabilities are ready, are passing, but also how many of those have not been implemented yet. So this gives us a pretty nice way of reporting progress. At a slightly lower level, we've got the feature coverage. So which feature has what tests, how many of those are passing, how many of those are failing. And at the very low level, we can show what steps are involved into performing any specific scenario. And this is very useful on systems that have audit requirements. So I recently had a conversation with a guy responsible for, actually the head of audit at the company I currently help with. And he basically said that when the auditor comes to the company, they don't necessarily care about the JIRA tickets that the system delivered, right? Or the user stories the system delivered. They want to know how the system works exactly right now at this particular point in time and how it got there. So if you can show them a commit log with a specific test execution report showing the exact steps involved in performing every specific scenario, that satisfies the audit requirements pretty well. So what does this look like? So when we run a Serenity.js test, we'll get the high-level release readiness report with some management candy, so pie charts. We'll have the capability breakdown, we'll have the features, we'll have the scenarios. So we can actually dive into any of those steps, into those scenarios, and see exactly what was involved and how. Okay, so some of the key benefits of using this approach. So if we structure our tests using reusable tasks, then by definition, the code becomes reusable. Now, each one of those tasks follows good design principles, so solid design principles. Each task has a single responsibility. It doesn't need to be changed unless the underlying business logic has changed. It can be substituted for other tasks, and so on. This approach scales pretty well, too. So if you think about it, all of those tasks that we design are just code, are just classes, functions. What we can do, we can package them up, and we can share them with other teams, with other projects, with other colleagues. What this means is that if we have a large system, let's say Amazon, right, that will have the search functionality, the product catalog functionality, the checkout functionality, we can have those different teams responsible for different parts of the system create a set of building blocks. And now if we want to assemble an end-to-end test of the whole system, we can. We just pull those dependencies in and execute the tasks. That's it. Should those tasks change, we just pull the new version of the dependency, and we've got a passing test again. One more thing that this gives us is the focus on the user journey. So instead of focusing on the page objects, on the structure of the page, of how we get to one place of the system to another place of the system, we focus on the user journey. So what tasks they need to perform and why they need to do that. So we capture this at every single level of our test. Okay, I hope I didn't bore you to death. Do you guys have any questions? And if we have any time for those, I don't know. Okay. Shoot.
Yeah, hi. When you're running two other things, we notice
Mm-hmm.
Is that something you address, Serenity.js addresses now?
Yeah, so the question was about the flakiness of the infrastructure. So how do we avoid flakiness of the infrastructure? By testing at the right level. So if we can execute most of our tests without using the entire infrastructure, so for example, by exercising the domain core itself, or the REST APIs on a VM, avoiding going through the firewalls, the load balancer, the clouds, the lambdas, and what have you, then that's how you can minimize it. You probably can't avoid it entirely, because you have a subset of tests that exercise the whole thing, but at least it won't be most of them.
That's one thing we noticed, though, like, because we're doing browser-based testing,
Mm-hmm.
it's like often something like Chrome auto updates itself, and that's now your feature is broken, and then you get the flakiness in the test. And it's no fault of yours now, your next thing is half a day you're spending just understanding why that
In one of your earlier slides, you showed a task specification that was implemented as if it was interacting with the browser directly.
Mm-hmm.
How does that then extend to interacting with the domain layer? Because it was talking about UI elements.
Mm-hmm. So that was the shorthand notation for the task. It was basically a factory where you specify the name of the task and you just give it some other tasks to perform. But what you can do is you can implement slightly more intelligent tasks. So any class that implements a task interface can be executed in this way. So what you can do then is you can either detect whether to run against the REST API or the UI or the domain layer in that particular task that becomes your dispatcher task. Cool. Any more questions? Or should we just all go and enjoy the sun? Cool. Thank you so much. I've almost forgotten all this stuff is on GitHub. So if you guys fancy, have a look at the repository, have a look at the tutorials. You can run them yourselves. And let me know what you think.